Just in case anybody's wondering, we've just got a few technical issues with the next speaker, so we'll be going live in a couple of minutes when they've got that sorted. Good afternoon, everybody, and welcome to the first afternoon at ALSA 2021. I've been remiss in the past, so I'd better introduce myself as opposed to that guy in the pants. My name is Valdemar Jacobson, and I work for a small consultancy in Brisbane called Brook Security. So, for our first highly technical session in this stream this year, we've got Dr. Weihan, Kevin Tan, and Patrick Kang from Project Enigma talking about detecting indicators of compromise through RAM analysis, event logs, and malware machine learning. And this is our first stream in this session that's completely virtual, and we've got 3 different speakers on 3 different virtual streams. So hopefully everybody remotely and locally can welcome the next speaker.
Hi, good day to everybody. Hi, my name is Kevin, and today I'll be presenting to you Project Enigma, an innovation that the team has been working on to streamlining and automating some DFIR processor. Sorry, I think I'm hearing double sound. Okay, never mind. So this presentation will actually cover the technical aspects of the tool, as well as a demonstration on how the usage is being conducted. Okay, so next slide, please. So just a brief introduction of the presenting team. The first member of the team, which is myself. I'm a second-year student in Singapore Institute of Technology, majoring in information security. Secondly, we have Patrick Kang, who is also a second-year student in Singapore Institute of Technology, majoring in information security. Next, we have Assistant Professor Dr. Weihan, who is also teaching in the Faculty of Infocom Technology.
Hi, everyone.
Next slide, please. Okay, so here's a brief outline of the presentation, where we will talk about some of the challenges in DFIR, brief landscaping of DFIR tools in the industry, our integrated solution to this problem, description and demonstration to the solution and the road ahead. Next slide, please. Okay, so one of the reasons why this project was actually created is actually to target 2 distinct issues faced in the geoforensics world. So firstly, we have actually a lack of integrated analysis solution where there was no automated software for RAM analysis. So even with the use of tools like volatility, forensic analyst has to actually manually type in commands and actually check files that are actually being extracted from volatility manually. So secondly, there's actually a lack in data triage hardware. So unlike hardware duplicators, forensic duplicators, there actually isn't a plug-and-play data triage hardware solution currently in the market. And currently, geoforensic analysts actually resorts to using software data triage solutions. Next slide, please. Okay, so in the DFIR community, there are actually many tools to serve their individual purpose very well. So we have like volatility and individual tools out there to do certain tasks for DFIR. And each of these tools actually require a lot of manual work, like such as typing in commands and knowing all the syntax for each and every tool. So in DFIR, some of this work is actually quite difficult to automate, as it actually requires professionals to actually look at these results and actually interpret the data to make sure that the data is actually correct and what it actually makes sense out of it. So here's actually how we come into the picture. So we are actually aiming to provide automation for some processes within the DFIR framework so that we can actually reduce the amount of manual labor needed. Next slide, please. Okay, so our team actually has come up with a solution to actually provide automation of RAM analysis, malware analysis, and event loss correlation. So this solution will actually consist of a combination of a hardware and a software, which we will go in depth in the next few slides. Based on the current development of the project, it's only Windows supported at the moment. And this solution can actually be installed on the host machine, or actually can be placed in the thumb drive and can be used as a portable version. Next slide, please. Okay, so this is actually the general architecture of the whole solution. We will use a scenario to describe the full flow of the solution. So firstly, the bash bunny will actually be used to collect data, such as RAM dump and event logs from the compromised computer. The forensic analyst will then collect the data and then pass it through our software solution. The software will first execute automated volatility commands to dump of the RAM dump and extract relevant data from it. After that, the software will actually then use an inbuilt portable executable analyzer and to actually analyze the PE files that are actually found within the RAM dump. And also we have an event loss correlator module where we will further analyze the event log file and actually correlate certain activities within the EVTX file. So after the whole analysis is actually completed, the program will actually generate a report and it can be presented to the analyst itself. So next slide, please. So I think some of you might ask, like, what is a bash bunny? So a bash bunny is actually a Linux computer built into a USB drive. And to use it, you have to arm it with scripts, and it will automatically execute the scripts when the bash bunny is actually plugged into the computer. So the general use of the bash bunny is actually for red teaming purposes. However, the team actually utilizes the pros of the bash bunny and tweaked it to use for blue teaming purposes. Next slide, please. So to talk more on the hardware configurations, we actually configured the bash bunny to perform two sets of instructions. For the first switch, we actually developed a PowerShell script to actually to extract security event logs from the computer, utilizing robocopy at the back end to perform data extraction and also hashing of the files and to maintain the data integrity as it goes along. A log will also be generated after the extraction is completed and for the purpose of audit trail. For the second switch, we use the PowerShell script to call upon an open source RAM acquisition tool called Dumpit. Due to internal memory of the bash bunny, the bash bunny only has 8 gigabytes of internal storage. It's not able to store RAM data above 4 gigabytes RAM dump. So we will actually use an external drive to complement this. So the user will actually have to plug in an external hard disk and plug in the bash bunny, and you will perform RAM acquisition, and the output will actually be placed into the external drive itself. Next slide, please. So to picture the bash bunny in action, I actually prepared a simple use case on how the bash bunny can stand out from the crowd here. So the current workflow is that incident responders will actually use software acquisition tools to actually extract data from each computer. And there also might be a risk of human errors during this process. So by using the bash bunny, we can actually just plug in the bash bunny into the compromised computer, and it will automatically collect the data that is needed. Once it's done, it will have a green light, and then you can just pull it out from the computer, and then you can move on to the next computer, and so on and so forth. Next slide, please. Okay, so now I'll be talking a bit about the software component of this project. So there are actually a few key functionalities that we will have, and we'll go into more details as we go on in the presentation. So next slide, please. Okay, so first we have the automation of RAM analysis with the aid of volatility. So how this works is actually we used Python to automate volatility processing by implementing a set of built-in volatility commands, which are commonly used for RAM analysis. So these inbuilt commands are actually, sorry, next slide, please. So some of the inbuilt commands are actually DLL dump, process tree, and net scan. So for DLL dump and process dump, we actually use these two commands to actually extract DLL files and portable executables, which will actually then be used in the next few modules that we have actually developed, which is the PE static analyzer, to actually look for indicators to show that it's actually a malicious program that is actually running within the computer. So next slide, please. Okay, so next we actually have a security event logs correlator within the solution. The program will actually take in a security EVTX file, and then it's being passed through a rule set, which is that we have collated based on event ID. So how this correlation works is that it will detect event IDs within the EVTX file and look for a sequence of event IDs or even individual event IDs and alert possible events that might have taken place in the computer. So next slide, please. Okay, so this is just a short list of what correlation rule sets that we have in this program. But we have the more notable correlations such as potential privilege escalation, lateral movement, and log-on brute force. Yeah, I will go into more detail for one of the rule sets that we have in the next slide. Next slide, please. Yeah. Thank you. So over here we have an example of correlation by event ID or detecting privilege escalation. So first, we will detect it in the event in a sequential order of, for example, 4624 or 4648, followed by 4672, like special privilege assigned to a new logon, 4704, user rights assigned, and lastly 4688, new process is created. So when we see a sequence of such events, we will actually correlate these event ID to be a possible privilege escalation. But of course, the analyst will actually have to himself double check this on the event log itself. Yep. Next slide, please. Okay, now I'll hand my time over to Patrick, who will be talking about the other parts of the software component. Patrick, please.
Hello, thank you, Kevin. Can you hear me?
Yeah, can hear you.
Okay, so now I'll be talking about our PE static analyzer module and how it works. So all DLLs and processes previously extracted by our RAM analysis module will be passed into this module for feature extraction and analysis. Next slide. So there are two main reasons why we decided to use only heuristics to conduct static analysis instead of using traditional signature-based approaches. So firstly, signature-based detection can be easily bypassed as a single change in string value or variable name will change the whole hash of the file, making it ineffective against zero-day attacks. And the second main reason will be that our tool was developed to be tailored for triage, which is part of the incident response framework. In the event where data breach has occurred, time is of the essence. And therefore, we did not include computational heavy techniques such as like pattern matching against a compilation of non-malicious strings, as it will require substantially longer amount of time to execute. So the PE analysis module works by sieving through files of interest for investigators and highlighting said files with high number of anomalies or suspicious properties based on several heuristic rule sets which we have implemented. So next slide, please. So over here are several notable heuristic rule sets we have incorporated into our static analysis module. So for example, having inconsistent checksum, size of code, and detecting file having multiple PE headers. So when a file is flagged for having inconsistent checksum, is an indication that a particular file has been either tampered or potentially injected with code without rebuilding the checksum value of the optional header. A file having multiple P headers is also a sign that it has been embedded with another executable into it, which is also an indicator that the program author had an intent to hide malicious payloads. So moving on next. Apart from heuristics, our solutions also incorporates entropy analysis, where it is being used to evaluate if a particular file has been either packed, encrypted, or obfuscated. Knowing if a file is being packed or encrypted is essential, as it is a common approach for malware authors to conceal their malicious code by using packers such as UPX, Termida, and so forth. So moving on next. So how our tool evaluate if a particular file is being encrypted and so forth are based on all these values. So based on the entropy value of the executable, our solution will classify each of them to be either encrypted, packed, or normal. If it has an entropy value of more than 6.926, it will be classified as encrypted. Files with entropy value lesser of 5.25 will be considered to be normal, or rather native and plain text. And for anything between the value of 6.926 and 5.259, it will be classified as packed. So next slide, please. So our solution will also be able to identify the functionality of the malware by looking into what WinAPI functions are being imported, and then classifying them into these categories as shown here. So the categories shown here are just some of the categories, they are not the full list. So how do we know if the file has a function of a keylogger and so forth? Let's look at the next slide. Next slide, please. So over here are 3 examples of identifying what functions an executable has based on its imports. So if we find that if the file will be indicated to have keylogger capabilities if it contains a series of WinAPI functions, like for example, get key state, get async key state, get foreground window, and so forth. As for checking whether it has anti-debugging capabilities, it will check for functions like create to help 32 snapshot and check remote debugger present. So moving on to the next functionality of our software component. So now let's talk about how do we predict if a P file is malign or benign with the help of neural networks. So we have gone over heuristics, entropy, and imports analysis. The next thing we can do is to predict if a P file is malign or benign with help of our automated neural network module. So next. So before we are able to train our model to predict the file, we will first need to collect data. So for benign files, we have manually extracted them from various multiple clean installation of Windows operating system, ranging from XP all the way to the latest Windows 10. As for malign samples, we downloaded them from various sources such as VirusTotal, MalwareDB, and other malware repositories. So next slide, please. After the collection process, we can then proceed with extracting features using our P static analyzer, and entropy analyzer, and imports analyzer modules, and saving those features into a CSV file. We then proceed with pre-processing the data and normalizing it before feeding it into a neural network for training. So after the training process, we evaluate each model's accuracy by using a 80-20 train test split. And currently, the best model accuracy we have is 90%, if I'm not wrong. However, we have only trained it against 14,000 samples. So next slide, please. So after the pre-training phase, we can then use the model with the highest accuracy by integrating it into our portable software solution to predict malware, to predict if P files are benign or benign. And the output will be a number of between 0 to 1, with 1 being malicious and 0 not being malicious. For files with a score above 0.5, our tool will flag it out for the investigator to look into. And now let's look at the neural network architecture that was used for training. Next slide, please. So over here is the architecture of the neural network. So the input is a vector of 73 numbers and is normalized to the range of 0 to 1. We then passed it into a shallow neural network as the data is not super complex with large dimensions. So we don't need a complicated neural network with too many layers. If not, the model will be overfit. So we use dropout to prevent overfitting, and we keep it simple with using sigmoid activation function for each of the hidden layers. So moving on to the last component of our software module. Next slide, please. Our software solution has VirusTotal API integrated into it, whereby P files will automatically be submitted to check if it has been previously detected or flagged. An API will be required for this, and for our case, as we are students, we requested for an API academic key, where it grants us access to up to 600,000 requests per month, up from the usual 30,000 requests from normal API keys. So you have the flexibility of changing the API key to your own API keys if needed. So next slide, please. Now we will have a short demo on how our software solution works.
Okay, so I was doing a voice over for this. So this is the bash bunny. So when it's actually plugged into the computer, you will actually see purple light. So it will show that it's actually starting up. Then after that, it will change to a yellow light. A yellow light is actually to show that the script is actually running. And after it's done, it will turn green. So this is what will happen on the screen when the bash bunny is actually plugged into the computer. So you will actually prompt this CMD, and you can actually see the whole process. But for the purpose of demonstration, I enabled the CMD to be in this way. But actually, you in the script you can actually edit and change it to hide the CMD in the background. So currently, it's actually collecting window event logs from the computer using robocopy. Yeah, and after it's done, so now this is the RAM acquisition portion. So as I mentioned just now, there's actually two switch to the bash bunny. So one switch will actually be used for event logs dumping, and the other one will be used for RAM dumping. So currently now it's actually dumping the RAM into an external drive. Yep, so now we'll watch the video for the software demonstration.
Software solution Enigma. So over here, the forensic investigator can see all the functions which are provided by our solution. So for case generation, it will pass all the case artifacts which were being retrieved previously by the bash bunny, and triage analysis will conduct a full analysis of all the artifacts and then provide a report. And in the event where the investigator doesn't actually want to conduct the full analysis and use the individual modules, we actually listed them over here. Yeah, the investigator can actually analyze their own files if they want, and their own secret Windows event logs. So let me walk you through. So now I will be passing all the case artifacts which were previously extracted by the bash bunny to generate a case. So over here, we will key in our name. Okay, so I will then browse to the RAM file which was retrieved by the bash bunny, which is this. And then just click execute dump. And just wait. The time duration will scale depending on how large the file is. Okay, well, once it's done, there will be a notification popping out the top right corner to tell you that it's finished. And now the investigator can actually proceed with the full triage analysis. So when they click on the side tab, they can access those functions from the home page or the side tab. It's the same. So when they click, they can just follow the instructions if it's their first time using. So over here is a brief summary of what kind of functionality it provides, what kind of thing it processes, and what kind of analysis it conducts. So so right after generating a case, we have to dump 2 extra files which were also retrieved by the bash bunny, mainly the event logs and some computer metadata info. So we will be copying over to our as you can see here, this folder was generated after generating the keys. So we just have to paste them here. And once we paste them here, we can proceed with the full triage analysis. So, we browse to the folder and select it and just click execute analysis and just wait. This will also, the time duration will scale based on how complex or rather how many files will be extracted also. So yeah, let's wait and see for the results. Once it finishes, there will also be a notification popping out at the top right corner. And once the results are being passed, when you scroll down to the bottom, you will be able to see this results tab. And over here, all the metadata of the host species will also be listed here. So some interesting thing like what kind of manufacturer and model of the host PC, and the number of processes that was running at the point of extraction, and how many domains and IPs were found, and the summarized number of all the potential suspicious and malicious files that are being flagged by our individual modules. And the flagged events are how many suspicious events that were being flagged by our Windows event logs correlator. So over here, the first table, it shows what processes were running at a point of time. The users can actually search what they want here also, based on their name. So the next table, we will also highlight what kind of IP addresses were being flagged out. Now, as you can see, there are 3 suspicious IP callbacks that were found. All of these, they are pointing to United States. And the next table will show all the executables that are being extracted. And all of the executables will be passed to our malware analysis module, whereby we will conduct a hash lookup using VirusTotal, and using our PE analyzer, we will extract any heuristics. We will provide a heuristics indicator score to indicate how malicious is it. And for the last field, which is the TensorFlow model, will indicate the prediction that was done by our pre-trained neural network. So as you can see, 1.79 is actually a very high value, with 1 being suspicious and 0 being the least suspicious. So we can actually sort it in descending order to see what are the files of interest to look at. So you can see this first executable is actually quite suspicious. It has a VirusTotal detection score of 42 out of 69, and it has 8 heuristics indicators. And the score that was detected by our neural network was actually quite higher. And aside from all the executables, we also analyze all the DLLs, as sometimes malware can be also injected inside. Okay, as for the last more table, which will display all the events log, all the suspicious events that are being flagged out by our correlator. So you can see there are actually signs of privilege escalation based on all the event IDs and timestamps. Yeah, and there's actually a Kang brute force that was potentially, they found instances of brute force attempts. Yeah, and that's pretty much it. And the investigator can actually save the results to look back at a later point of time. The event where they want to view the results later and process another case currently. It will be able to save it as a JSON file. They can save it as any extension. Okay. Once they save it, there will be a notification. And they can actually review their past results from their homepage of the site tab. So we can, my case today, review case. Yeah, they can. This is the case that was the demonstration case. Yeah, that pretty much sums up my software.
Hi. Now, we've seen what this tool is. We've seen that it's actually a combination of a hardware and software solution. If you look at the hardware itself, we talked about Bash Bunny. Now, Bash Bunny, like what Kevin have talked about just now, is a tool that's typically used for red teaming, for attack orchestration. The scripts are run by the Bash Bunny emulating HID keyboard and so on. So it's actually a tool that's meant more for the attacker's side. Now, the road ahead for a project like this, for this project essentially, is one thing that we've been thinking about or we've been looking at is basically how can we create a purpose-specific device to replace Bash Bunny, right? Because we know by now we know what Bash Bunny is. We know what it can do. It lacks certain features that are desirable for forensics. For example, you can use a Bash Bunny, but you may not know whether it's you can put in the scripts and everything like that and ensure that things are, for example, forensically sound on your end. But is there a way, for example, to make it more obvious to at least the people who are who may look at you using this tool, right? So things like, for example, internal logging, read-only components, write on toggle, and so on. So the road ahead, one of them is to actually build a purpose-specific device for this. We have actually had a few ideas on how to do this so far. So we're still in exploratory stage. For example, using Raspberry Pi W, and with some custom software that's built on top of it, right? Together with maybe some measurement architecture that will measure everything that's being executed on the so-called Raspberry Pi itself, right? The next two things, or the other things that we can do. Now, if you look at the project as it is right now, it's still pretty. I would say it does things, but we can improve in terms of what it can do. So, like for example, currently we only process security event logs, or i.e. the security.evtx. We can look at for example, expanding it to support more kind of events, event logs, more kind of logs, and correlate between those kind of logs to see, whether certain things are actually happening or not. The third thing that we can look at is, of course, to use a larger data set to train our neural networks. Currently, because this is a project that's meant to be exploratory, the data set that we use is, I would say, sufficient for the purpose of demonstrating the capability of the tool. But of course, with more data, results will definitely be better in this case, right? So these are some of the things that we see that we can potentially do. Next slide, please. And the source code for all this has actually been released. All right, the GitHub repository can be cloned with documentation available online. So if you want to try it out, you can actually go and try it out. Right. But more importantly, we're also looking at how to actually improve this tool, how to actually add in more features, what are the things that we can potentially do, what we mentioned just now, for example, a new hardware that pairs well with a software like this, and so on, so as to allow the same seamless plug and play, but at the same time on more forensics kind of platform, right? So if you have any questions, you have any you have any ideas, or you wish to collaborate with us in terms of this, feel free to drop us an email. Kevin and Patrick's email are there, right? My email's at weihan.go@singaporetech.edu.sg, right? So feel free to drop us an email, discuss about the project. I mean, we are open to hear ideas, see where we can, what we can work on, what we can improve, and so on, right? So thank you for listening. There's QR code there. If you want to take a look at the video demonstration again, you can scan it. You can take a look at it, or you can just distribute it to to whoever you think might be actually interested in a project like this, right? So yeah, thank you everyone. We open the questions if we are there.
We're pretty much out of time, unfortunately, but there are a couple of questions here. I'll try and rip through them extremely quickly in the last minute. Is there a capability for the investigator to compromise the event log correlation and change the thresholds of the models?
Okay, so this one, there are two ways of looking at it. One is they compromise the event logs itself. If they compromise the event logs,
I was reading way too quickly. My apologies.
Compromise. So what's the question? Could it customize the event logs?
That's correct.
Right. We're looking at expanding the capability of the tool, right? Like what we mentioned just now, whether we can, include more kind of event logs, so that we have, a better picture of the whole system that we're actually looking at.
And the other really quick one for you to answer is there any plans to allow for remote collection without using the bash bunny?
Remote collection without use of bash bunny. All right. So the premise of using bash bunny is because, well, a lot of the work that goes with collection is typically done manually, right? With in stuff and everything like that. So the idea is if you have a bash bunny loaded with scripts, and this emulates what an analyst would do, right? Yeah, that pretty much automates the whole process. If you talk about cloud collecting through the cloud, if I understand the question correctly, collecting all this data through the cloud, we need to look at it from a different perspective. It may not be a hardware anymore, maybe a software module of sorts. Either that, or it could be, for example, a remote, some kind of a Linux distribution or something like that. So the device where we plug it in, perhaps using the same concept as bash, this bash bunny kind of thing. Plug it in, and this device then establish a connection over the internet of sorts, and somebody can control it at a remote end to actually retrieve this data. More simpler approach would be, well, plug in this device, data gets collected, data gets automatically sent to the cloud, which is something that we actually thought of as well. And this is actually a more, I would say, quite a straightforward approach if we do really implement this.
Great, thank you very much. Very informative talk.
All right, thank you.
Okay, we've only got a couple of minutes, everybody, so we just need to move quickly to the next session. We've got 3 minutes if you wish to change rooms.